In the ever-evolving landscape of technology, a concept looms on the horizon that promises to reshape the very essence of human-machine interaction: artificial general intelligence. Often portrayed in science fiction as sentient robots or hyper-intelligent computers, AGI represents the culmination of human ingenuity, a leap beyond the boundaries of mere automation. This video embarks on a journey to unravel the mysteries of AGI, rendering its complexities accessible to all, and exploring its significance, challenges, potential benefits, and ethical considerations. In the early days of computing, artificial intelligence was conceived as a means to replicate human-like cognitive abilities. Yet these early AI systems were confined to executing specific tasks within predefined boundaries, aptly termed narrow AI. They could master a game of chess, translate languages, or classify images, but their knowledge was rigidly compartmentalized. They could not traverse the vast expanse of human intelligence, adapt to unfamiliar situations, or generalize knowledge across different domains. This video aims to provide a comprehensive yet accessible explanation of AGI, its significance, challenges, potential benefits, and the ethical considerations that accompany its development. So before we continue, make sure you subscribe and turn on notifications so you don't miss any of our future videos. The evolution of AI, from narrow to general intelligence. Over the course of its evolution, artificial intelligence, AI, has progressed from its humble beginnings as specialized tools to the grand prospect of artificial general intelligence, AGI. Initially, AI systems were tailored for narrow tasks, demonstrating prowess in activities like chess or speech recognition. These early AI iterations followed rule-based programming, performing well within confined domains but failing to generalize knowledge across diverse contexts. Yet the relentless march of innovation led to the dawn of AGI, a transformative leap that seeks to imbue machines with the capacity to comprehend, learn, and adapt across an array of intellectual domains. AGI pivots away from task-specific expertise to emulate human-like cognitive versatility. Unlike its narrow predecessors, AGI leverages machine learning principles, enabling it to learn from extensive datasets, draw connections between seemingly disparate domains, and exhibit a level of intelligence capable of mirroring human comprehension on a broader scale. The foundations of AGI, artificial general intelligence, AGI, is built upon two pivotal learning paradigms that form the bedrock of its development. The first is supervised learning, where machines learn from labeled training data. This approach involves feeding the machine a multitude of labeled examples to enable it to discern patterns and characteristics that distinguish different categories. For instance, in image recognition, a machine learns to differentiate between images of cats and dogs through exposure to numerous labeled images of each. The second paradigm, reinforcement learning, draws inspiration from behavioral psychology. It focuses on the principle of rewarding correct decisions and penalizing mistakes. Through this process, machines learn to navigate complex decision spaces to maximize rewards. This method is particularly evident in training AI agents to excel in video games, where they learn to make optimal choices based on the outcomes of their previous actions. These two learning paradigms collectively lay the groundwork for AGI's ability to process data, generalize knowledge, and make informed decisions across diverse domains. Challenges in achieving AGI. Developing artificial general intelligence is a formidable undertaking, fraught with several intricate challenges. One of the most significant hurdles lies in the realm of computational power. AGI demands vast computational resources to process, analyze, and learn from the immense volume of data required to emulate human-level intelligence. This requirement constantly drives researchers to push the boundaries of hardware capabilities to meet AGI's insatiable appetite for computing prowess. Furthermore, AGI development grapples with the intricacies of data quality and quantity. The efficacy of AGI hinges on the availability of high-quality data for training purposes. Acquiring and curating such datasets, especially encompassing diverse domains, poses a continuous challenge. The inherent variability and biases within data sources necessitate vigilant efforts to ensure that AGI systems don't inadvertently adopt or perpetuate biases during the learning process. Balancing the need for voluminous data with its accuracy and fairness is a delicate task that underscores the complexity of AGI development. The potential impact of AGI. The emergence of artificial general intelligence has the potential to profoundly reshape our world. Its impact spans across various sectors, triggering transformations that were once the stuff of science fiction. AGI-driven automation, for instance, could revolutionize industries by enhancing efficiency and productivity. This transformative shift, however, raises concerns about potential job displacement and the need for upskilling the workforce to adapt to these changes. Moreover, AGI's ability to swiftly analyze colossal volumes of data can accelerate scientific discovery and innovation, leading to breakthroughs in fields ranging from medicine to climate science. In healthcare, AGI's potential is significant, enabling early disease diagnosis, predicting outbreaks, and contributing to drug discovery. In the realm of education, AGI-powered personalized learning experiences could cater to individual learning styles, revolutionizing how knowledge is imparted. The integration of AGI into autonomous systems, such as self-driving cars and drones, holds promise for enhancing their efficiency and adaptability. While AGI presents remarkable opportunities, it's essential to tread carefully, addressing ethical concerns and implementing safeguards to ensure that its deployment remains aligned with human values and benefits society at large. Ethical considerations and safeguards. As AGI advances, a host of ethical concerns becomes increasingly pronounced. Among these, the issue of bias and fairness takes a central position. AGI systems, if not properly guided, can inadvertently perpetuate biases ingrained in the data they are trained on, leading to outcomes that are unjust and discriminatory. Hence, diligent efforts to recognize, understand, and rectify these biases are essential to ensure equitable AI systems. Transparency is another vital facet of AGI ethics. As these systems become more intricate, the decisions they make can often seem inscrutable to humans. Establishing transparent decision-making processes within AGI is vital for holding these systems accountable. By fostering transparency, we enable better comprehension of the factors guiding AGI's choices, thereby enhancing user trust and overall societal acceptance. As the journey toward achieving artificial general intelligence accelerates, humanity stands on the precipice of an epochal transformation. AGI promises a future where machines possess human-like cognitive abilities, revolutionizing industries, science, healthcare, and education. However, this extraordinary potential must be accompanied by an unwavering commitment to ethics, transparency, and collaboration. The development of AGI demands a holistic approach that transcends technological prowess. Ethical considerations, from bias mitigation to value alignment, must be at the forefront. Striking a balance between innovation and responsible use, while fostering a collaborative ecosystem involving researchers, policymakers, and the public, will shape AGI's trajectory. As AGI pioneers, we bear a profound responsibility to ensure that its integration into society reflects our collective wisdom, aspirations, and a commitment to harness its power for the betterment of all.